Hello, this is Tor Lacey with a lecture about the early Paleozoic eon, which, for the sake of this discussion, will include the Cambrian and Ordovician periods that happened 542 to 444 million years ago. Let's start with the paleogeography, or the arrangement and physical processes happening on continents and in the atmosphere during the early Cambrian. As seafloor spreading rifted the ancient continent Laurentia, North America and Greenland of today, away from the supercontinent Gondwanaland, the passive margin between the continent and the mid-ocean ridge slowly subsided. This increased the area of the continental shelf submerged under the sea, resulting in enlarging the shallow marine habitat and depositional setting of North America. The sediment deposited during this time is very mature, being nearly all well-rounded, well-sorted quartz grains, reflecting prolonged erosion being transported long distances by streams and wind. This tells us that the Laurentian craton stood well above sea level during this time. Wind erosion appears to have played an abnormally important role during this time. Why? No vegetation on land to interfere with wind currents. The climate changed as Vanadian glaciation, snowball Earth, ended. The warming climate melted glacial ice and sea levels rose, further increasing the area of offshore sedimentary basins. The Sauk transgression refers to stratigraphy that records rising sea levels as transgressive sequences. For example, in the Grand Canyon, Cambrian strata is deposited on significantly older Precambrian rock, making what is known as the Great Unconformity. Sea levels continue to rise until the early Ordovician, flooding continents worldwide. Life of the early Paleozoic is about the sea. Animals developed more sophisticated burrows, indicating increased behavioral complexity and foreshadowing the diversification of life to come. Organisms generally became larger, and some evolved shells for better protection and locomotion. And most all life that evolved during the early Paleozoic belongs to existing phyla. Life of the early Paleozoic is about the sea. Animals developed more sophisticated burrows, indicating increased behavioral complexity and foreshadowing the diversification of life to come. Organisms generally became larger, and some evolved shells for protection and better locomotion. Most all life that evolved during the early Paleozoic belongs to existing phyla groups. Fossils from the early Cambrian include small tubes and teeth, and Timotean fauna, some of which resembled modern-day sponges. Later Cambrian life was dominated by trilobites, arthropods with segmented calcite exoskeletons and compound eyes. The earliest invertebrates evolved at this time, as did large predators, like the anomalocarids, which grew up to 6 feet long. Sea levels dropped from the middle towards the end of the Ordovician, as the climate cooled and water was stored in glaciers instead of the sea. Near the end of the Ordovician, the climate warmed, glaciers melted, and sea levels rose once again. At the end of the Ordovician, the eastern margin of Laurentia is a convergent plate boundary, causing a collision with an island arc that intensely folded and metamorphosed rock, building an ancient mountain range in what is today the region of New England. There was a great diversification of life during the Ordovician, with many animal groups evolving that are still around today, including corals, bryozoans, brachiopods, mollusks, echinoderms, and graptolites. These new animals ate stromatolites and burrowed into their structures, resulting in their decline. Coral reef communities also developed. In the late Ordovician, there were 2 pulses of marine extinction. The first was brought on by global cooling and the growth of glaciers, which led to a drop in sea level and resulted in one of the greatest mass extinctions in Earth's history. Life on the seafloor was decimated, and many groups of brachiopods, trilobites, conodonts, and corals met their demise. Life in the shallow seas also suffered, with acritarchs, graptolites, conodonts, and nautiloids going extinct. When the climate warmed again, glaciers melted and sea levels rose, triggering more extinctions. During the early Paleozoic, life as we know it evolved. Diversification and extinctions were driven by global cooling and warming, as evidenced by the stratigraphic and fossil records. That's all for now. Thank you for your attention.